Good afternoon, everyone. Welcome to today's webinar on harmonizing algae-based LCAs and selecting systems and data providers. I'm Mariana Carneiro. I am an innovation manager at Necton, and I am delighted to be here on behalf of the organizing projects Realm, Locality, CMARC, CIRCalgae, and ALGAE-PROducts. This event is meant to be a reflection on the collaboration across multiple EU-funded initiatives working towards the common goal, ensuring LCAs for algae-based products are robust, comparable, and truly reflective of the sustainability potential of our sector. As many of you know, at least the ones working with algae, conducting LCAs for algae-based systems is far from straightforward. Different cultivation techniques, processing methods, and end-use applications create significant variability in the results and makes it difficult to compare studies or extract clear sustainability insights. Hence, algae-based solutions have gained significant traction across multiple industries, and with this growing relevance, we must also ensure that the environmental impact assessments of these solutions are accurate, transparent, and standardized. This is why we, across our 5 projects, came together to co-organize today's webinar. Since we have a limited time slot, we had to choose to focus on a specific topic within the LCA. Among the many challenges in harmonizing algae-based LCAs, we chose to focus on process selection, because the way we define and structure LCA processes has profound implications on the outcomes of our assessments. So over the next 2 hours, you will hear from experts actively working on these challenges within our projects. We will discuss how process selection affects LCA comparability, what are the main issues, and how we can address them. Our goal today is not just to share knowledge in one direction, but to spark discussion, identify synergies, and work towards solutions that can benefit the entire algae sector. Here we have our program. We have a very packed program in this upcoming 2 hours. Starting with Marius Stulgis from the European Commission to talk about the EU support to algae sector development, followed by Luis Esperanza from Green Collab, representing the project Locality, Tom Bradley from Discerna to represent the Realm project, Jona Schnuck representing from Wageningen Social and Economic Research, representing the CMARC project, Martin Luke from Civita to represent the CIRCalgae project, Jean-Baptiste Thomas from KTH Royal Institute of Technology Stockholm on the ALGAE-PROducts, and finally our moderator Leah Braud from the EABA, which will moderate the panel discussion after the project presenters. Now I would like to thank our esteemed speakers from the European Commission and the research institutions and industry partners as well, and also appreciate the participants attending, and hope that you will enjoy our webinar. Go ahead, Mike.
Thank you, and hello everyone. I'm really glad to see so many people here in the call. I would really like to start with appreciating and congratulating the organizers of this webinar of 5 projects really coming together, because it's really fundamental that EU projects are not working each in their own corner, but they are working together and they are building on the success of each other. And delivering something that is useful for Europe. I'm in the European Commission in DG Mare, and I'm in charge of the blue bioeconomy and algae file. And among other things, I was involved in developing the EU algae initiative that was adopted in end of 22. Maybe the font is too small, but I think that you will see these slides afterwards. So the EU Algae Initiative was developed based on the political decision taken at some point by the Commission around 2020, I think, where it was decided that the Commission will develop a dedicated initiative to support algae sector developments. But in parallel, of course, there were many other work streams, for instance, these 5 projects that are co-organizing this call are really a result of this increased support to the algae sector that was decided, and these quite substantial amounts allocated to algae sectors projects is demonstration of that. So to support algae sector developments, that there are four main action areas that was based on the impact assessment done before, which are the need of improving governance and legislation, looking at the business support mechanisms, raising awareness and acceptance, and driving research, knowledge, and innovation. Okay, I will not go through all these boxes here, but just to outline that we don't work in DG Mare alone. So we certainly work together with all the Commission DGs. And as you can see, there are synergies with other Commission policies initiatives, with DG Environment, with DG Climate, GROW on finances, with Common Fisheries Policy, Industry, with DG Santé, and we are having inter-service group really to coordinate with the relevant services to see what's necessary for algae sector to develop. We have our project European Algae Stakeholder Platform, EU4Algae. You might have heard about that. That has around 1,000 registered members. And we are also working closely together with the national authorities to really see what developments are needed and where we can streamline the processes. Okay, life cycle assessment. Of course, this is important aspect to ensure the credibility of the algae sector, because we need to have proofs that algae sector is having lower environmental impact than other sectors. And we have incorporated this already into the EU Algae Initiative, as you see on the left. Yeah, it's a Commission communication called towards a strong and sustainable EU algae sector. And life cycle assessment is basically necessary to understand and assess environmental impacts of growing algae industry and specific steps on how to act on them. So, and it indicates that there are more actions needed to assess the impact of local biodiversity, environmental footprint, and proposals for compensation measures. It also indicated that there is a need to more studies and monitoring programs to assess the potential negative effects and proposing risk mitigation strategies. Life cycle assessment for each product is also needed to prove that algae products are having lower environmental footprint, like its land-based counterparts. So that we need a scientific proof to really ensure that there are sustainable decisions are taken, and we are. Yes, and one of the actions that was included into the algae initiative was Action 8C, where the intention was to work with industry and member states to support life cycle assessment of environmental and climate impact of algae cultivation and production by considering the development of monitoring methodologies and indicators to measure environmental impact and sustainability from seaweed cultivation. So how did we do this so far? Of course, there is a number of projects that are looking at life cycle assessment of algae. But from our side, we have included this into the terms of reference of the EU4Algae and also of the algae industry study that are specifically looking from various aspects. And these two are working hand in hand together to ensure that both projects are complementing each other and delivering on this in a complementary manner. Yeah, okay. This is bit of the theory, but I think that these are three important terms that needs to be understood. Maybe there are quite good life cycle assessment specialist here in the call, but as I'm not myself, so maybe just to outline that we are what we are talking about. So life cycle assessment is really aiming to provide valuable, comprehensive and quantitative information on the environmental performance of products and services used to assess, support sustainable product and consumption. And also it provides a scientific basis for policies on products to design, consumer information, public procurement, waste management, energy and food supply. So this is really important to have proper life cycle assessment for policy making, whether this is for to implement algae initiative or any other product related and other initiatives, policy initiatives or legislations, then life cycle assessment could and should play a role. Life cycle thinking is the basic concept referring to the needs of assessing burdens of products, sectors, and projects, adopting a holistic perspective from raw material extraction to the end of life. So this is basically a long way to go from the raw material extraction to the. Sorry, is there problems to see the slides or is it okay?
It's okay. It's okay.
Okay, thank you. Yeah. Yeah, and then the last is life cycle costing. It's defined as an economic assessment considering all agreed projected significant and relevant cost flows over a period of analysis expected in monetary value. Yeah, okay. This is just to show that the EU has already made significant steps to integrate life cycle into a number of its policies, like the bioeconomy policy or single-use plastics directive, in sustainable investments, and so on. So it's I will not go into details here, but it's just to demonstrate that it's already in the policies, and the Commission will continue to work on that. So now the rest of the slides were kindly provided by something wrong. Okay, yeah, a number of slides were provided by my colleague Mauro Codella from DG Environment, and DG Environment is specifically looking into these environmental footprint and life cycle assessment aspects in the EU policy. So as you see here, so product environmental footprint is based on several pillars and assessment methods, and key here is that each layer aims to build on the one below. So we start from the bottom with the ISO standard on the life cycle assessment, and there is a EU recommendation on environmental footprint methods, and you go up of fine-tuning really the information on the life cycle assessment on the relevant standards and methodologies. Yeah, okay. Here is the environmental footprint journey. As you can see, that the predecessor of the current results and current work and methodologies goes back to the 2003. Again, I will not go into details, but you see that there has been quite substantial developments since 2003 on developing the environmental footprint and life cycle assessment in the EU. So, but the work is really in the process. As I mentioned, our colleagues in DG Environment are busy in digging deeper and providing more comprehensive framework for the life cycle assessment of the products more in general in Europe, not only algae products, but of course, as this is about different products, that it applies to algae products as well. And here you can see the timeline, which is mostly of DG Environment on environmental footprint future next steps. You see that we are currently in beginning of 21, where there is a specific steering group of DG Environment that is looking in further methodological and rule refinement involving the inter-service group, which is the Commission internal inter-service group with various services. And then in Q3 of this year, there is a targeted stakeholder consultation planned. And then there is an inter-service consultation on draft recommendation, which is the formal process of the Commission to formalize the legal acts and policies. And then the formal adoption of the new environmental footprint recommendation is envisaged early 26. If we look at okay, not sure what happened, but some of my slides disappeared here as well. I still had some more slides, but okay, we can make sure after the event that my slides are in, because there is still some methodological developments that I wanted to outline on related to the harmonization of footprint methods and also on the specific impacts on the oh, okay, I see them here. Something is wrong. Okay, it works. Sorry.
2 minutes,
sorry,
Maris.
Yeah.
Sorry.
Okay, fine. Yes. So if you speak about environmental footprint in future, that here you see that the different categories that are to be taken into account when calculating the life cycle assessment. And these are the really specific categories to take into account, like climate change, ozone depletion, toxicity, particulate matter, eutrophication, and more. So these are the ones to consider in future. Here are some methodological developments, as I mentioned, also linked to the Commission regulations like land use change and carbon removal and carbon farming regulation that are in place already, and they have implemented some life cycle assessment provisions there. And there is also envisaged revision of other impact categories and addressing regionalization, like water scarcity or soil quality. Yeah, okay, this is the last slide. And then of course, the review is based on scientific progress, experience in application, input of experts, stakeholders, and so on, and of various working groups and also on various projects. And I think that the good outcome of this process that was kicked here would be really, yeah, to develop the valid methodologies of calculating the environmental footprint of different products, algae-based products, ensuring that, for instance, for the same product, there is not a different life cycle assessment result. Normally, for the same product, you should have a same result in terms of environmental footprint. And this is like important maybe criteria to take into account, that methodologies are so solid and developed and harmonized that we have more or less same result for the same product. I think that's it. Thank you very much.
Thank you, Maris. We'll move on to Laish. Can you take control?
I think so. Can you see it? So I'm Laish. I'm going to present in behavior of locality to compare LCA of micro and macroalgae products. So approaches and challenges on the project. So to begin with, what is the scope of the project? The locality stands for the nature positive algae-based food, agriculture, aquaculture, and textile products based in North and Baltic Sea ecosystems. So it's composed for 27 partners of 14 countries, with the mission of restore our ocean, seas, and waters by 2030, protecting and restoring ecosystem and biodiversity for zero pollution and carbonization, and lighthousing the Baltic and North Seas. So in 2 phases, they want to develop and piloting, and then deployment and upscaling the technology of these 3 main ecosystems in North Sea. There was like aquaculture, agriculture, and the textile products. So the value chain, it's based on these 3 systems and 3 products, like textile product as antimicrobial and dyeing additives, the biostimulant and biocontrol products in the agriculture, and the functional aquafeed products, and also producing some food products as like protein alternative as fish analog, meat analog, egg analog, and nutraceutical products. So the idea is to have the sustainability of 3 circular industrial ecosystem plus the product. So LCA in macro and macroalgae. So you have the macroalgae system being cultivated in the seawater, going to the biorefinery, and the microalgae cultivated in the drinking water for the 3 facilities, textile, aquaculture, and agriculture greenhouses, to make the direction to the biorefinery and producing the products. So based on our methodology, the idea is to have a attributional approach, can be by apples, but as like the European recommendations, using allocation cutoff by classification. And that is a question because depending on how the other projects wants to build on, we are able to change because we haven't really started the project yet. The LCA part is going to be starting this year. The idea is to have a boundary from cradle to gate, so finalizing the LCA in the product, so the ingredient that is leaving from the biorefinery facility to the applications. The functional unit and allocation will depend later on the biorefinery design and product. Probably is going to be mass allocation for the product delivery from the biorefinery. And the LCA is going to be done in 2 parts. So the cultivation system, so in fact it's like 3 water sources for microalgae and macroalgae system, and the biorefinery that are going to be separated, and then we can put this together with the data collected from the producers and in a scale that is going to be defined, because some of the phases are going to be in pilot scale, so we're going to need to scale up a little bit to get the proper LCA in the real life. The secondary data is going from EcoInvent database, and the impact is going to be calculated by the PATH method, all done in OpenLCA software. So thinking about the system processes and data providers, we can see for now, as I said, we haven't started yet, so this is a preliminary study. There is not a lot of information in the databases for algae cultivation and biorefineries. If you think about seaweed cultivation, the only thing that we could find is like it's really hard to get the primary data, as there is a lot of interference from the environment, especially like when it's open shore and offshore production. And we have like a uva process in Agribalis that in fact came from laminaria process that are growing offshore from hops. And there are like 2 main, that is optimized and not optimized in France. So this is the only provider that I found. In the case of microalgae production, there is nothing in the database, not even for the cultivation, so photobioreactors or open raceways. And there is a lot of challenges in defining these technologies in the cultural media, because even the media, when you're inputting, there is not all the chemicals or vitamins present there. And in the case of biorefinery, we have some equipment, so some drying or extraction, but details need to be checked. And especially the other point is also the electricity that is in the biorefinery is quite a lot and needs to be updated to the current grid, and not just trusted in the EcoInvent that is being outdated for now. So we are always updating that as well. So the results of the project, as I say, it's too early for the results, but we already can highlight some challenges, especially in comparing micro and macroalgae products, because the production systems are different and the utilizations are different. So you can have three things that we can see. That is the scale, the definition in the future, how big it's going to be, especially when you're going for the European projects. The transportation that is usually ignored, and we need to see how this is going to be working. And the functional unit that might vary quite a lot, especially when you're comparing products from the biorefinery. So the idea is to have all the variability and uncertainty assessed by sensitive analysis in the project, and the results are going to be divulgated in the end of the project. So just to conclude the idea of the locality, micro and macroalgae-based products are new value chains in the LCA. So there is not a lot of direct proxies on the databases, and there is a lot of room to improve. And I think this webinar is good because we can start this conversation. The main limitations in providers are especially in technology. So there is a lot of new equipment and complex biological processes in the algae sector. So that is not straightforward in the databases. And that is also in the macroalgae special scenario, has a lot of interaction within the environment, and how to deal with that is also a challenge. How we are going to put in these interactions that is not a closed system. So I think the harmonizing and discussing the LCA processes and methodology is crucial to more understandable and comparable results. And I think these are our introduction of the locality and what we are facing for, and hope to see what the other projects are doing, and we have a fruitful discussion in this webinar. And that's it from my side. Thank you very much.
Thank you, Lee. We'll move on to Tom.
I think I've taken control. Yeah, cool. So, so I'm going to talk about the Helm project and the kind of challenges and things that we've had and around the methodology, the data and the baselines. And I'm Tom Bradley from Discerner, which is a commercial spin-off from what was the UK National Renewable Energy Centre a long, long time ago. So the project. So the scope of this project is that it's taking agriculture and aquaculture and using the runoff and the waste and transforming them into useful materials, using algae essentially as a vector for this. So the drain water from agricultural processes in greenhouses is very nutrient rich, and this is used to feed microalgae production. Nutrients obviously a very large impact when considering microalgae production, so using something that's recycled is better. And then the microalgae themselves be used to produce a range of things such as bioactive compounds and other useful things for the agricultural sector, and also producing materials for aquaculture. So the idea is that you've basically got a unified food production system which has got agriculture and aquaculture and microalgae production all together. So the partners in the project are everyone who's listed here, including Green Collab, which have I put Green Collab's logo on there? Oh, yes, yeah. So working with Green Collab, working with Necton, and a range of others who are either presenting or attending today. The kind of value chains that we're looking at. So a number of other things to mention outside of the overall concept that I gave is that, for example, we are looking at using direct air capture to supply some of the CO2. This is not to turn the whole thing into a carbon sink, because that's not going to happen with the way this is designed, but it will reduce the impacts from getting CO2 from industrial sources as is normally done. Therefore, it will reduce the overall impact of the system. We're at the very early stages of modelling this. The systems themselves are being designed and over the next year or so will be constructed, and then there will be real data available. So why do we care about LCA? Well, I think this has already been covered by the previous two presentations, and will be covered even more by the presentations afterwards. But essentially, the whole concept of this project is about sustainability and about making microalgae production more sustainable and about making food production more sustainable. So we need to validate the project claims, because you can't just go along and claim something will be sustainable and then hope the Commission doesn't notice. So it's about validating this, but it's also, and the really important thing about LCA is it's not just about saying that something is good or bad, but it's also about finding out where the hotspots are. So understanding how we can reduce the impacts. And that's why LCA is very important to be there during the whole process of design and build and operation, and not just at the very end as some kind of score sheet. So it's not moving. Why isn't it moving? There we go. So the methodology, very similar to in previous presentations, ISO 14040, 14044 compliant life cycle assessment. We're using Open LCA. It's open source, which means that you can add on extra things to it if you need, and you're good enough with Python. And one of the nice things about it is it's got the collaboration server that allows Discerner and Green Colab to work on the same model at the same time. We're using EcoInvent, also doing social life cycle assessment using the SOCA database, integrates with EcoInvent. A really important thing is that the models are parameterized. So instead of hard coding every number, because research projects change everything all the time continuously, this means that we can then adapt to any changes and also run various scenarios, and it makes other things easier, such as sensitivity analysis, etc. And we've been using pedigree matrix assessments for uncertainty, which there's many ways of doing uncertainty. We like this because it's kind of a measure of ignorance, and it avoids the kind of false accuracy that some other uncertainty methods give you. I've got too many slides. I'm going to talk faster. So it's based around systems in Portugal and Spain, cradle to gate system boundary. We're assuming 15-year operational lifetime at the moment. The impact categories, we're using using the PEF ones plus AR6 climate metrics, because nobody really has got the AR6 climate metrics done correctly in their impact assessment methods. There's gases missing that are important. Including in terms of the data, we've undertaken numerous site visits. We've got energy monitors for large bits of kit, reviewing new data on the designs as things change. Big difficulty is that it's a research project, so it's constantly changing. And the data is coming from Nectar, it's coming from Biohorizon, and we have a whole range of different bits of equipment. So talking about what this is about, the system and the data providers. So data, we've got previous projects like Magnificent and Intersuzal. We use the literature. We've got EcoInvent, which has its issues, Algae-Based, and also data from other databases, but not merging databases, because that would be a terrible thing. And internally, we've built a decent microalgae lifecycle inventory data library that we're organizing, so it can be more useful. But one of the things is everyone does this. Everyone is creating their own individual models of photobioreactors, of any particular chemicals that are outside of EcoInvent. And we're all doing the same thing over and over again and making the models slightly different, so all our results are not comparable. And that's where data providers becomes really important, where all wasting our time doing the same thing over and over in a way that's not making it repeatable. And this doesn't just extend to the algae data, but also the baselines. So, for example, we're looking at baselines of fertilizer, we're looking at macroalgae comparisons. We're going to have more that are decided as the project continues and we learn more about which sectors we're going to be competing in. But looking at previous projects as well, we've looked at beta-glucans, phosphoxanthin, phospholipids, looking at Antarctic trawlers, which I spelt wrong, walnut oil, biodiesel, fossil diesel, food products, protein-based estimations. And so it's not just the data on algae, it's the data on what are we all comparing with all the time, because otherwise we then end up making different decisions about microalgae as well. So whilst primary data is always better, EcoInvent has holes, Algae-Based fills in some of the holes. And for us, we're using data gathered by the Discerner, but we need to collaborate to reduce this repetition. Am I running out of time, Melanie?
2 minutes.
Okay, oh, that's all right. I'm nearly finished. So the results at the moment for the project, everything's preliminary. We're building the models for the CO2 capture and for the infrastructure at the moment, whilst Green Collab is working on the biorefinery elements. So we don't have any data to show at the moment, and any data we would show right now probably wouldn't be right because we haven't finished. Uncertainty, yeah, the pedigree matrices are really useful for finding all the bits of 15-year-old data within EcoInvent that might have an impact on our models. So that's something we're doing. The main challenges, it's a research project, so everything's changing, but when we're also considering publishing this on a collaboration server so it can be downloaded at the end after it's adapted, so there's no IP issues. But to get around to the overall message, the kind of things we're learning and everyone else is learning, we all rely on EcoInvent, and it's full of holes and approximations, and everyone knows that. Research work such as Horizon is always difficult because everything changes continuously as people learn new things. The ISO standards themselves give too much freedom in general. But the main thing is everyone has their own selection of models of things that are not in EcoInvent, and it would make a lot more sense, instead of doing the same thing over and over again, to combine our efforts and have some kind of combined set of data. So I can't remember who originally suggested that. It wasn't me, it was somebody else. But one kind of model we could look at is the stuff done in the US where they've disappeared down an open source rabbit hole, and the LCA Commons has been created where all their research with LCA results from different government departments is all in the same format. It can all be combined together. It's one massive lifecycle inventory database. Sadly, does not connect with EcoInvent. And that kind of model, something just so that we just stop making different models of the same things over and over again and getting different results. There we go. That's that. Finished. Yes.
Thank you, Tom. Let's move on to Yona. Please take care. We cannot take questions at this moment, but please share them for the panel discussion after presentation. Go ahead, Yona.
Yeah, thank you for the presentation so far. I will talk about the CMARC project. The CMARC project in general is about European macroalgae cultivation and processing. There are a few objectives. They were in here, I won't read them, but one about the LCA is the fourth objective, to get scientific evidence on the environmental benefits and also the risks of macroalgae production and processing. There are a lot of stakeholders involved in the LCA related task. It's ocean rainforest, oceanian fermentation experts and ALGAE. I don't know if you can see the picture that well. On my screen it's a bit small, but the slides will be shared afterwards. Well, within the LCA work of the CMARC project, we will assess three, they call it most promising products. So in the whole project, we defined 12 products, macroalgae-based products, and we selected 3 as most promising projects. In the picture, you see that there are a few on the TRL 5 level, up to TRL 8 already. And that was at the start of the project. At the end of the project, they will probably be, or they are expected to be at the right side of the arrows. The 3 products we will assess is a seaweed-based fiber, a sulfite additive, and a green alginate. So the seaweed fiber, we will assess it from a cradle to processing facility gate stage. It's a dry powder, so it's dried seaweed, and we will compare the product with the land-based alternative, which is fructo and galacto oligosaccharides. For the sulfate, we also do a comparison with the land-based product, but there it's an additive, so there's source fat with the seaweed-based additive and source fat without the additive. So that will be the comparison, and we will compare the weight of the piglets leaving the farm. And as far as we know right now, it's good for the health of the source and the piglets if they are fed with the additive. And the last product is a green alginate. The conventional alginate is also macroalgae-based, but this green alginate is processed with less energy and less chemicals. So we will compare it with the conventional alginate production. How do I get on? Yeah. So the methodology we apply is that we also use an attributional approach. We defined the four steps of LCA in the workshop. Of course, the goal and scope, which is the first step of conducting an LCA. So the main goal is to compare the three products, the algae-based products, with our land-based alternatives. Now and in the future, because now some are still very lab-based, and in the future there will be a scenario that there's the production is upscaled. Then the next stage is the life cycle inventory stage, and which is currently running. So there are 4 partners involved, and we are collecting data. Well, so far we have about 50 to 70% of the data. Deadline is February 2025, so this it's coming soon. Only the data of the green alginates are a bit delayed, so we will get them in March probably. Then we did not yet define the LCA method we will conduct. We will discuss with the other partners which is the most preferred one. And of course, the interpretation at the very end and the reporting. Well, as I told, currently we are in the data collection stage, so we do not have impact results at this moment, but we face some challenges. The first one is that data collection is always, it always takes time. We have 4 partners involved, and they're sending us a lot of data, which is very nice, and we really appreciate that and thank them. But it takes time. It's a bilateral process that takes time. As I told you, the green alginates are a bit delayed. They run some pilots, and the next pilot will be in March, and hopefully we will get the good results by then. And then the next step will be the modeling of the processes, which will start next month or for the green alginates after March. So far we face some challenges in the modeling with the data we received right now. And first, I would like to discuss some of the challenges with you. So the first one is about the seedling production, or the chemical inputs for the seed production and the seaweed cultivation. For the seaweed cultivation, they use biobinders. It's like a glue. They stick the seeds to growth lines, and it's a bio-based material, glue, and the conventional one is based on epoxy, but there is no process in the LCA databases that contain this bio-based version. It will probably not be a hotspot in the total impact, but it's interesting to know that better, and maybe one of the other products also face or the products are cultivated with this glue, so it would be interesting if we can harmonize that. Another gap is the nutrient medium and the growth medium. There is no media like that in the databases, and also their composition can differ. So yeah, it would be nice if we have a database with media data. We also face some challenges regarding the industrial equipment. This will neither be a hotspot, the manufacturing of the equipment, but still it's good to have more insight in it. So for the seaweed processing, they use drying machines. And apart from the production of the machines, they use a lot of energy, which is a hotspot. And we have primary data for the drying processes if the partners do dry it themselves, but some of the partners, they also let other organizations or other partners do it. And we do not have the primary data, so then we need some proxies for that, and the database do not provide these proxies.
1 minute, sorry.
Oh yeah, sorry. For the fiber processing, there's also reactors needed, and for the alginate extraction, blenders and filters. So also machines. Let me see how. Yeah. Okay. I have 2 more slides only. So then we also face some challenges for the fermentation process, which is about the bacteria. Do we include them or do we exclude them? They are needed for the fermentation. There's some literature, so we can build a model based on that literature, but we would like to apply the same processes as in the other projects. So the last slide is about the conclusions and the main messages we have so far. So harmonization and of the processes and proxies from LCA database will be very helpful to come to comparable results. But beside the process selection, I think it's really important to harmonize on other methodological choices as well, like that we define, well, at least approaches for choosing your system boundaries, the cutoffs we do make or don't. Also some definitions about the requirement on primary or secondary data, which is important to do. The other PEFCR so far, they do define which data should be primary and which should be secondary. It would be nice if a kind of PEFCR would be developed for the seaweed-based products as well. Of course, allocation. We have systems which provide more than one product. So in that case, we need to apply allocation. And especially in this innovative and lab-based products, it's really hard to apply economic allocation because there's no economic values yet. So mass allocation could be a solution, but the best is, of course, to do a sensitivity analysis on more than just one allocation approach. And of course, the impact assessment method, that we choose the same method. Yeah, so we are very, very happy about the LCA community we have on the algae, micro and macroalgae-based products. And we are looking forward to come to a harmonized LCA standard. So thank you very much.
Thank you, Jana. We'll move on to Mart.
Hello, I'm Martin from Circalgy, and I will talk a little bit about the LCA approach currently known to me for Circalgy. So, the scope of the project is rather grand, as in we are using waste streams of currently industrially relevant micro and macroalgae waste streams, and because we're trying to perhaps create something from things that are currently not being extracted, are being treated as waste, so to produce maybe food, feed, and cosmetic ingredients. So it's a new blue biorefinery concept. So it's true valorization of these underutilized side streams. And it's mainly for the consumers and algae producers to see perhaps through this LCA whether the approach would prove helpful. And currently, I'm also having an issue that it seems that the slide is rather small. So hopefully when people receive the slides later, there's the process of CircAlgae as a consortium shown there. Hopefully it's a bit more understandable when you have it on a bigger screen. And we will do an initial LCA-like estimation on the parameters that we find for processes, because we are analyzing 15 products at the moment, and only up to 5 will be chosen as the end products which will be upscaled from the laboratory level. So at the moment, the exact targets of the LCA research are not exactly clear in that sense, because the LCA will only be conducted for the chosen products. But an initial parameter-based analysis will help to determine which ones are going to be upscaled or used as in the project. So our biorefinery cascade processing of microalgae is divided into these sections, I would say, or we have several different steps where we are looking at the things that could be taken out. I've just put out the main products that were being produced in the case of microalgae and examples of the processes. Currently, not all of these processes will end up in the final LCA. And it's pretty much the same if we're talking about red algae. We have the products shown and all the processes that might be relevant, but might not also at the same time and in the end. And also for brown algae. As you can see, this is a nice strain of how alginate is produced, but at the same time we have 2 or 3 places where we can take the waste streams and analyze them to perhaps create the other products. And also we have a lot of different processes, and in the case of if we use a earlier step, some of these processes in this flowchart will not be used in the final analysis. Regarding methodology, the choice was to use product environmental footprint methodology. The goal and scope will be heavily affected by the final product chosen for the LCA. Boundary planned at the moment is cradle to gate, analyzing the initial algae cultivation as well, and the life cycle impact inventory according to the boundary, with some data pre-collected for a preliminary assessment that I mentioned earlier. And the life cycle impact assessment is going to be according to the PAF-EF rules, environmental footprint 3.1. So interpretation is also going to be heavily dependent on the assumptions made. But at the moment, we have chosen this approach, or the product environmental footprint methodology, because it's the European Commission's initiative for harmonization. And it's hopefully a way to align with further projects being developed. So systems and data providers, we will be using main, let's say, data system for us, CIMAPRO, with the EcoInvent database, even though it has its own misgivings, let's say, it does still have a lot of useful data, and CIMAPRO as a tool has various methodologies which can be accessed to perhaps complement in this case. And it does have a lot of resources. Also, hopefully we can add to it, but we'll see. And as I do not exactly know the thing, or let's say product, which will be the main analysis focus, the results are very broad, foreseen results. Variability, especially because we are talking about upscaling, and also uncertainty will be, as usual, I think, important. We will have, as earlier speakers have also mentioned, allocation issues, especially it's for us due to the fact that we're using waste streams, and LCA main outcomes will be disseminated by the Circology project. In conclusion, I would say that at the moment it is too early to provide more in-depth choices besides some general approaches, but hopefully this will have proven useful and informational. Thank you.
Thank you, Martin. Oh, let's move on to Jean-Baptiste.
Thank you, everybody, for those presentations so far. Can you hear me? Everything okay with the sound? Yeah, good. Yes. So my name is Jean-Baptiste Thomas. I'm a researcher at KTH, Royal Institute of Technology. I've been working with LCAs of seaweed systems and microalgae for quite some time now. This isn't my first rodeo, as they say. Problems that we're facing, though, with doing algae LCAs haven't changed. They're still very much the same as I think practitioners have been experiencing over the last 10 years or so. So I'm here to present to you ALGAE-PROducts. I'm also working a little bit with Martin on the CircAlgae project, but ALGAE-PROducts is the focus here. So the scope of the project is, again, it's to try to focus on the development of these algae products, hence the name ALGAE-Pro, in the Baltic and North Sea region. That's the BANOS acronym. So algae products in the Baltic and North Sea region. Similar to some of the other projects, we have a lot of partners. There are products from TRL 4 and 5 to TRL 7 and 8. That's sort of the goal, to try to push them up. We have 26 partners coordinated by Submariner, 20 key exportable results from 9 work packages. There are 8 products being developed from 6 pilots, and a mix of both micro and macroalgae. All 8 products are to be studied in some way or another by the LCA work package. We're at the moment splitting it into 2 phases. So a streamlined preliminary assessment for all of the pilots in order to give them some useful feedback, and then we'll go into more detail in a select few towards the end of the project in phase 2. So again, 8 products in the pipeline, and we're facing similar challenges in that sense as the rest of these projects. We have, research-based LCAs. We're dealing with systems that are constantly changing and evolving, which is exciting, but also very challenging when inventory data keeps shifting. Scaling issues are also going to be a challenge. I'm not sure that's really been mentioned so much in the past presentations, but managing the comparison of different value chains at different scales is a real problem in LCA for fair comparisons. Sometimes comparing is not the right answer at all in these situations. In terms of the methodology, again, very similar to what we've heard already so far. We're following the PEV methods. Functional units will be determined on a case-by-case basis, depending on the products. And of course, baselines will also be selected on a case-by-case basis, but also in collaboration with the other projects here. Hopefully we can find a bunch of baselines that we can all compare to for specific product types. Again, main objectives here are to raise awareness of the value chain impact hotspots, provide feedback to the producers, identify optimization strategies together with them, and to plan for more sustainable scaling and substantiation of their green claims as their products reach market. So I mentioned, yes, there are these 2 phases. First, there's going to be a streamlined attributional LCAs of the existing value chains, and then phase 2 will be more prospective of potential scale value chains. And this will be focused on just a couple of the products. The status is that right now we're hoping to finalize the golden scope by March, and we will begin phase 2 in September. So life cycle inventories are ongoing for the pilots at the moment, where everything is just sort of starting to kick into gear. So we're still quite flexible in terms of methodological choices. So this seminar comes at a good time for us. So main messages are similar to the other presentations. I have the fortune of being last here, so I don't have to repeat so much, but I would highlight one thing that hasn't been mentioned either, is the second bullet point here, that I think LCAs are not just an opportunity to optimize value chains and to substantiate green claims, but also really to educate people through participation. So the whole process of going through the LCA as a pilot is an opportunity to learn about the impacts of value chains. And that's something that I consider both a challenge and a really fun part of conducting this work, or doing LCA work. I think within the ALGAE-PROBANOS project, we, together with SIKE, who I should have mentioned, are also involved in the LCA work. That's the Finnish Environment Institute. We're hoping to develop, really to focus some of this effort on developing this harmonized LCA method together with all of you in these other projects. So I think that was my last slide. Thank you.
Thank you, Jean-Baptiste. And thank you to all speakers for the key insights from each project and for keeping up with the time. Now we'll move on to the panel discussion featuring all our speakers and moderated by Braud from the European Algae Biomass Association. We have prepared an interactive survey related to Algae LCA, and we ask that participants with Algae LCA experience to please scan the QR code to participate in the survey. And also please feel free to leave questions in the chat. We will do our best to place them forward. So now I'll give the word to Leah.
So first, welcome to the final part of today's webinar. I think it was great so far. We've heard so many insightful presentations on various algae-based products from very interesting ongoing EU projects. So that was really great. And we learned a bit more about some unique challenges when it comes to performing LCA studies of algae systems. And that's what we're going to dive in a bit deeper during this panel discussion. And we will focus on one issue in particular, which is the issue of process and data selection when it comes to modeling an algae system in the software, so after data collection on site, and how we can, based on this, improve comparability, which has the speakers mentioned, comparability is essential, and harmonization would be a step forward. So we'll address some other challenges as well, and I think I really want to discuss about scalability too. So we're going to see this as well. We encourage everyone in the audience to participate as much as possible. So I've seen in the chat that there were already a few questions. I couldn't keep track, so Melanie and Marina will help me with that. So please don't hesitate to list the questions so we try to cover as many as possible. And yeah, I guess let's get started. So I think to start with, I would like to bounce back on what Lais and Joanna said several times, and it was also mentioned by the other speakers. So Lais, you talked about the Agri-Based database, which is for the people in the audience who never heard that name before. It's an open source database which focuses on the agriculture and food sectors. And it's so it's free to access and has several thousand data sets already, and a few on seaweed especially. So Lais, you had some experience trying to navigate through this database to find some data. And then you also mentioned that there's no data set for microalgae at all. So there was one question in the chat asking if there is any microalgae-based database available yet. So I guess we already have the answer. But maybe we could elaborate a little bit on this with Joanna as well. we mentioned specifically some equipments, for instance, drying equipments for seaweed biomass. So how do you handle those data gaps? When you go on site, you have to, so you collect your data, and then on your computer, you have to model those machineries where you cannot find any data for. So how do you handle those data gaps? And is there any specific processes that are in particular lacking for data and that would be of high priority to cover in the next months or years, let's say? So maybe Laïs, would you like to start with that?
Yeah, sure. So as you said, at the moment we find a lot of gaps and not really a lot of answers. And we have the approach of trying, like, especially with equipment, we don't have the proper equipment, but we try to talk with suppliers to see the weight of the equipment, the main compositions. So for example, metals, or like the membranes, you have the materials or the glasses for the photobioreactors. And we try to make like the different parts of the equipment by ourselves. But as I said, this is a really internal database for each equipment. And it would be interesting to see how the other people is also approaching that to maybe become the things more comparable.
Okay, great. Thanks for your answer. And I think, Tom, it's probably your time to jump in. And I will cite you again, but you said instead of doing things again and again, and you repeated this several times. So indeed, it would be a dream actually to be able to compile this type of open source database for macro and microalgae. What do you think would be the next step to take? Because you mentioned that internally in your company, you already have several data sets. So what format should this be? You mentioned the LCA Commons. Can you tell us a bit more about this?
So yes, I mean, we've got a selection of data that we're starting to pull together into an organized format from all our previous projects gradually. So things like LCA Commons are very nice because that is there is a set methodology as to how the LCA should be done, how the flows and processes are treated, etc. So that it's not one big database; it's lots of small ones that everyone can connect together. So it means that then the data is available for everyone within different US government departments. I think the first thing that needs to be done is kind of, I mean, what we're doing here, to be fair, is understanding what are the processes that everyone has to model, because it's not there in pretty much everyone uses EcoInvent with AlgaE-Based or SOCA or something else combined on. What are the things that are definitely not there that we always have to remodel over and over again? So getting that list together as a priority list, which is, to be fair, what we're doing, is an important thing. And then, I guess, reviewing the literature to understand where there's a lot of data out there in supplementary materials that's just been lost in papers that have, been read by a few thousand people, but the data should be used far more. And the kind of format, in terms of format, if it aligns with something, then that kind of attracts people. So if it aligned with EcoInvent, it'd be useless to somebody who uses LCA Commons for everything. So I guess having it in a format where maybe make it in a format where it can be connected with databases, fair enough, but also have it in a way so that the data is there in a form so somebody could just replicate the models from looking at the life cycle inventories in whichever tool of choice they have. So not making it so it supports any particular proprietary thing like EcoInvent, but having it so that it can be used with anything. Did that answer the question, or did I just ramble?
No, that answered the question. Thanks, Tom. So okay, cool. From what I understand, I feel like there would be two types of harmonization. The first one trying to harmonize LCA methodologies applied to the algae sector, trying to ensure that future studies are comparable and reproducible. And then there would be the other standardization part, trying to make the most of what has been published already. So indeed, coming out with such a database would be really, really great, and hopefully it will happen in the next few years. Joanna, is there anything particular on this priority list that you would like to add based on your experience in your projects?
Yeah, I think, well, we are not yet into the modeling, so it's a bit forward-looking for me. But I think it's really important that we have data or processes, that we choose processes, or that we choose the same processes for the energy use. For example, if the partners themselves do not dry, for example, the seaweed, so it takes a lot of energy, and if they let other people dry it for them, then we don't know their energy use. So then we need some proxies for that, and because that's a hotspot, it's really important to get good information from literature or from other projects. And what I also would like to add is that we have to be aware about the confidential data. So if we want to build a database based on the results of former projects, we have to be aware that some of the data that are used in that project could be confidential data. So we have to think about a way how to deal with that.
Yeah, that's a very important point. And yeah, this confidentiality issue arises actually very often in those EU projects, especially when small companies are involved, right? So maybe aggregating data at process level would help with confidentiality, but again, this would be a major hurdle. Jean-Baptiste, do you have anything to add related to the use of proxies and to fill in data gaps based on your experience?
The use of proxies, you said?
Yeah.
Yeah.
Yeah, when we don't have data and we try to fill in the gaps.
It's a key part of this work that we have to do. I can take any number of examples. A classic one for me has been ropes in modeling seaweed farming systems, long lines or raft systems at sea, or let's say, I think earlier we heard other examples. We talked about drying machines is another good example, or fermentation processes. All of these systems don't exist in these databases, or may not have suitable equivalents. So you then have to draw on products that are similar in their manufacturing process, or that have similar performance, and motivate this in some way. So for ropes, a classic example is to use fleece, which has got some good processes in online. That's been one approach that has been used. Others just use the granulate of the plastic without any sort of manufacturing process behind it for the material. So the fleece process is you're using the manufacturing process as a proxy plus the granulate. So you have these different approaches, and it is a challenge, and it would be great, as everybody's been saying, to have better quality data for both micro and macroalgae, for primary production and processing. With a concerted effort in that direction through a project in the coming years, we could, probably put together some very good quality data for these things based on the projects that have already been done and existing data that's now published, as Tom was mentioning, in supplementary materials pasted across our journals. So yeah, I'll stop there. I think that answers your question.
Yes, very well. So you suggest, for instance, that LCA practitioners in the algae sector sit down and come up with a data set for ropes, for instance, to be able to then increase comparability between seaweed-based LCAs.
Yeah, that's one example. But I think LCA has not evolved to cater to marine product systems. It's evolved to for agriculture, for energy, for forestry. It's not really had the same amount of investment put into it to develop processes and things. So even boats at sea, we don't have processes that are equivalent. Pump systems for water, thermoregulation of raceway reactors. These things are all key parts of these product systems that we're working with that we don't have data for or access to anything reliable. So it's ropes is one example. There are many, and that's a real challenge for us to deal with. And yeah, coming together for better data would be great.
Okay, so we should keep adding things to this list of high priority processes to cover in order to increase comparability. Okay, so that's very good. I'm going to ask Melanie and Marna now if there is any question from the audience that we should address next.
Yes, I think you already answered the two first from Anjali. And then there's the first one was, are there any open LCA databases tailored to microalgae? And the second, what are the most reliable data sources for conducting an LCA on microalgae-based carbon capture systems?
Maybe, Tom, you can actually bounce back and give a bit more details on this second question, since I know you were involved in carbon capture projects, right? If I'm not mistaken.
Yeah, we've done carbon capture of microalgae systems, so that's appropriate. I mean, to be fair, when we did that, we used EcoInvent and some of the knowledge we'd got on some of the internal information we got on algae processors from previous projects we worked on. So, yeah, in terms of an actual database we used, it was just EcoInvent because it was, in that particular case, it was for it's Brilliant Planet who were going to be talking to investors. So EcoInvent is respected and known by everyone because it's, in some cases, the only database people know about. As far as I know, I hope I'm wrong, but I don't think there is anything out there with a lot of decent information on algae processors. I really hope I'm wrong. I hope there's one massive one out there somebody's about to say.
No, I think you're not mistaken. That would be, we would know it if it existed. Right. Marna, any other question?
Yes. Does anyone know or uses the software EcoChain from Elena? I think there's a link also to the EcoChain.
Anyone with experience using EcoChain?
I've not used it myself, but I know of it. My understanding is that it is a very useful software for doing sort of more streamlined. I'm not sure if they would be defined as streamlined, but they're definitely not as detailed as the types of LCAs that we would be conducting. I'm also can't confirm this off the top of my head, but I think it's actually one of the few sort of streamlined tools that's also PEF and ISO compliant. So I don't know if any of my colleagues can confirm that. So it is useful for companies, but for doing really complex LCA work with multi-product outputs and this kind of thing, I don't think it's suitable. And unfortunately, biorefineries and algae systems, seeing as they don't have the data to begin with to do the LCAs properly, unfortunately, I wouldn't trust such a tool for our sector yet. But it may be very suitable for others that have been subject to many more LCAs than ours. For now, yeah.
Okay, just to relate, sorry, Elena answered that the question was, could we try and use it in the algae industry, which Jean-Baptiste already answered to, but she's heard that industries like it. I don't know if
yeah, there are equivalent tools in the construction sector and others besides. So this kind of thing is emerging, and yeah, it could very well emerge for the algae sector in the future. But we have some way to go before we can get to that point.
If I may add something, I've never worked with it, but I just know a little about it as well. And it's very user-friendly software, so that's very nice, and that's why industry partners like it, because software like CIMA-Pro, that's not that user-friendly, so to say. But it's more like a black box. You just choose a few processes, and then you have the output, but you cannot play around, so to say. And we as researchers, we want to understand what's happening. We want to do the sensitivity analysis. We want to do a lot, which is, yeah, EcoChain is not made for that. So it's made for a user-friendly tool.
Jean-Baptiste?
I would also add, I saw that Massimo commented on the point that I made earlier about LCA being an opportunity to learn about our value chains and to understand impacts. That's one of the best possible use cases for LCAs to elevate our understanding. That's really hard in a black box software like this. You get a report at the end, which would be useful for your reporting to the EU, sustainability reporting, so on. But then you're missing out on a lot of opportunity there in between, which I hope that us as researchers here present will deliver to the pilots in our various projects.
Good, thanks. Marina, any other question?
Yes, we have one more. Who fits from BANOS? Who fits EcoInvent's database? How is it evaluated and how is it certified?
So who wants to answer this question?
Seems none of us want to.
Yeah.
I try. I can start. Please correct me. So it's a Swiss research agency, but they don't just collect data themselves. They get data from a range of places. For example, the reason there's so much data from Quebec, you'll notice if you ever go through it, is because that's come from research that was done in Quebec, separate from EcoInvent that was given to them. Same goes for some of the Brazilian data as well. So it's a research centre that also gets data submitted from other LCA projects globally, which is why you sometimes see massive amounts of data that's incredibly specific for incredibly specific geographies or specific technologies. As to how it's reviewed, I don't know. When you go into the EcoInvent database, you can normally find the papers or the sources that it gets the data from. So, for example, if you look at photovoltaics, that was based on a lot of information from the International Energy Agency. And most data you can go through and you can find the individual papers or the individual reports that it comes from. So that's gone through the peer review process. But as to if there's any kind of final validation within EcoInvent, I assume there is, but I don't know what it is. That's a kind of answer.
Does someone want to add something to that? No? Okay, good. Okay, before we take another question. Yes?
Sorry, just continue.
No, I was actually gonna go to the next point, but if you have anything you want to share, maybe some answers to the survey or the 3 questions asked?
No, there was one question left, but then you said before you take another question, so. Okay,
yeah, maybe there's one, the point on scalability, I think is really important to discuss. So if that's not the topic of the question, then we might just jump into scalability now and take the question after, if that's okay.
Sounds good.
Okay, perfect. So many of you mentioned that the EU project you're working on focus on products that are at low technology readiness levels. And that's also the aim of all the EU project, right? To scale from TRL 3.4 to 6.7, etc. And EU projects really evolve rapidly over the 4 or 5 years they're running. And that raises some challenges regarding data collection and how we handle also the scale up. So I would like to ask you for your experience with scaling data. I know that, Morten, you actually mentioned the variability regarding scaling up. So maybe you can share some experience with us on scaling up data in EU algae projects.
Well, the scaling issue mainly arises from the fact that you start at the lab level, but in the end you are going to try to make a production scheme in, let's say, a biorefinery factory level. You're just going bigger, but at the same time, many parameters and even maybe inputs can change in this regard. So already you are getting changes to your inventory in in this way. So this is constant re-evaluation of the data you have gathered and how to change it, and if the process in its core has remained the same. Because if someone can do something in a lab, they will most probably use a very different approach from a production facility. So that's the main issue there, especially if it's as said, moving from one TRL to another.
Yeah.
And I think this was already referenced in Tom's presentation regarding the constant change, if I'm not misattributing it.
Yeah, exactly. And I think, Tom, you also mentioned that you're using parameterized inventories. And this is very useful when it comes to evolving data, right? Because then you can feed in your model any data you want and actually easily or more easily account for the scaling up. So what is your experience with parameterized inventories, Tom?
Our models use a lot of parameters, and yeah, we've learned to do that out of necessity because all the data changes every few months at times, as is the nature of research. So it helps a lot in terms of scaling up. We work a lot with others within the projects who are better at explaining the scale up between, say, lab scale or pilot scale to industrial scale, to help us with that information. But in terms of using parameters in general, I think it's the only way to actually do a project that's got a lot of research in it, because it's the only way to deal with the amount of times that the data changes. Otherwise, you'll just spend your entire life going through the model, changing numbers over and over again, as every month something's changed.
And you use OpenLCA as a software, and you find it really easy to implement the parameterization. I mean,
I love OpenLCA. I'd never call it easy. I think it's better than everything else, but I'd never call it easy. It's once you know how to do it, it's logical and reasonable to do. I wouldn't say it's intuitive.
Okay. Yeah. Anyone else who has experience with parameterized inventories or want to share the experience regarding scalability in EU projects? Lais, maybe. I know that you are at least working with different scales and trying to collect data for that.
Yeah, the good point with like most of our companies that we're working, they are already in a large scale, so you can get the data directly from a large scale as well. But this is kind of like a challenge when you're working with like research projects that are like small scale, because this is not only about the parameters itself, but the kind of efficiency and other things. The OpenLCA is quite good because you can add the parameters and you can just change it and, for example, put it in scale on efficient in a equipment, and you just change that value and he makes the calculations for you. But of course, like it's important also, I think, to bring not for only the people from the LCA, but people that are really working with the equipment. So talking to the people on the biorefinery, because sometimes they have much more knowledge on the scaling the process than us. And it's quite important to rely on these kind of connections and understanding to how this is going to be working in a different scale, especially like in terms of like saving resources or water for like the washing processes or recirculating material. This can change quite a lot when you're changing scale, and it's important. It's not only a question of parameter, but understanding the process and how it's going to work in a different size.
Thank you. Jona, do you want to add something to that?
Yeah, in our project, for example, the lab scale version, the seaweed is cultivated and the yield is, they cut it by hand, so it's just humans that go there. And in the future scenario, there will be vessels and more mechanization to get the yield. So we got that data from interviews, but of course it's a bit future scenario. So they base it on their expertise so far, but it's good to have these parameters that you can play around and make some uncertainty analysis as well, because you don't know. But we got the data from the interviews with the partners.
Okay.
And
great.
literature as well. Yeah.
Okay, you mentioned future scenarios, and that really rang a bell. So Jean-Baptiste, you mentioned in your presentation the word prospective. So looking at impacts of emerging technologies in the future once they're deployed at larger scale. And we know that the prospective LCA community is growing really fast. And I know that in the audience, we have some prospective LCA experts as well. So Jean-Baptiste, maybe can you just give us some insights about how prospective LCA could be relevant for the algae sector?
Thanks for putting me on the spot, Leah, in front of the experts. We have, so it's sort of, as you said it, I mean, it's fairly self-explanatory. They're typically sort of more future-oriented and acknowledging the fact that there are these larger uncertainties with these developments that are coming. So expected changes to the value chain. So it's kind of just acknowledging this, as I see it, as a framework. And there are lots of aspects to that. But generally, I think for LCAs like this, where we have, technological developments, that's a key part of the systems that we're working with. These are research projects where there are pilots that are trying to improve on their technologies. They're trying to scale up what they're using and optimize systems. Then it's just a framework that makes a lot of sense to aim for. Deploying scenarios and so on in order to try to work with it. And I think, of course, we've been talking about parameterized inventories. I think that's also a really valuable approach to combine with this.
And I think, Lace, you mentioned in your presentation as well that some data in EcoInvent are outdated indeed. And for instance, looking at the energy mix would be really important because algae systems consume so much energy, right? So in this case, using prospective LCA, well, in my opinion, would be really interesting for the algae sector. So that's maybe something to look into as well. Anyone want to add something on this scalability and prospective LCA topic?
Yeah, there's the issue of product substitution or replacement of products. A lot of the green claims that we find in the algae sector are based on, this algae-based product is better than this alternative. And actually substantiating that through LCA when we're dealing with low technological readiness and small-scale algae systems with these really large-scale, well-established sectors. If we take bioplastics, for instance, a seaweed plastic bag or a plastic bottle does not compare favorably to a fossil plastic bottle simply because we're dealing with a monster of an industry that's highly optimized and has had a very long time to optimize its production. So this is another part of the scalability issue, another dimension of it, you could say. How do we make these benchmark comparisons with systems that are really well established? That's a real big challenge that we have to face. As I mentioned in my presentation, sometimes comparison isn't the right option. We have to substantiate green claims in a different way or have these important asterisks marked next to the results and explain these things in detail. It's a challenge, but it is something worth mentioning here.
Yeah, I think that's really important as well. So do you have any experience with upscaling if you don't have access to pilot or industrial scale data? I would say, Lace, you said that you for instance, have access to large scale data directly. And I think that's quite a luxury as LCA practitioners to have access to such data. And most of us really deal with lab and pilot scale data. So in this case, of course, there are simulation software that we can use, such as Pen Plus or Learning Curve, maybe to try to do a decent or fair upscaling, but still, as Jean-Baptiste mentioned, comparing algae-based products to large-scale commercial equivalence is an issue. And we can take the example of plastics, but also animal feed or basically anything. Does anyone want to add something about this or personal experience on comparing with conventional products? You mentioned that most of you use allocation, so economic mass allocation. I heard in your presentations. Has anyone performed consequential LCA, doing substitution? Maybe you can share your experiences with that.
Yeah, I just want to share about like comparing. That is also something that we see, that even though we say, oh, this is already in the market, sometimes we don't have the LCA for that. It's not because it's already a structured product that we have all the data for that, because most of the companies also keep the process by themselves and they have the claims. So it's not all the benchmarked products, especially in the algae, like what algae is being coming for, like replace, or we want to substitute or even gain share in the market. It's not so simple to compare. And we need to see that most of these LCAs on the databases have been done in specific places or a specific time frame that consider some other things. And now us in the algae sector, we are going for like really deep, the process that sometimes the database doesn't go in this level for the benchmarked process. So it's important for everybody that are using the LCA for comparing, also look to that, and then not just getting the other ones from the database or something, but getting like proper LCA done for the benchmark as well. So just to complete this part, I think it's important to say that.
Yeah, I think, Lace, you nailed it down quite well. So it's not only always about algae data, it's also about finding good data for the products we're comparing algae with. And that's also a challenge sometimes. I'm taking this opportunity to jump into another stated topic that you mentioned as well in your presentation, functional units. When we compare products, right, algae and conventional products, the functional units becomes of very high importance. And we know, for instance, when we look at food products, comparing kilograms of algae with kilograms of conventional food is maybe not the best or the most accurate way. Do you have any thoughts regarding functional units and in comparative LCAs?
Yeah, in my experience, we really need to understand what we are going for, because some people are going for just like protein. You have now this nutritional LCA as well. There is the protein that the people really can take, and we need to analyze the values of the parameters. But again, it's quite hard when you're saying that it's just like 100 grams of protein of algae compared to 100 grams of beef, but you don't eat exactly the same amount in a meal. So there is a lot of room to be discussed, as you said, it's not really a straightforward question. I think like a lot of us has even different opinions on this question. I think like when we are going for a protein source, maybe protein content is the best functional unit, but I'm pretty sure if you're going for a different kind of food, maybe this can change a little bit. I'm going to let my friends talk a little bit about it.
Thanks, Lace. Jean-Baptiste.
I think Lace hits the nail on the head there. Perfect first answer. Yeah, and I've worked in a project where we used I think it's called the relative nutrient density score, or very similar, NRF, I think is the acronym. So it has a number of different indicators for nutritional density, 21 positive indicators and then 3 negative, like saturated fats, this kind of thing. And then from that, it aggregates a final score of nutritional density, or sort of food value. And this is an interesting way to compare foods. It's one of the ways that I know is being utilized in LCA comparisons for food products. But yeah, this is a really complex and interesting question. I'll let you on that. add to this as well.
Thanks, Jean-Baptiste. Jona, please.
Yeah, I'm working on another project on this nutritional LCAs, Jean-Baptiste, with the NRF. It's not that straightforward so far, so I know, but it's a bit out of topic for now, because I think we also use a lot of algae-based products for non-food applications, so it's good to keep that in mind as well. And I think it's really important to find out case by case what is the real function of the product you're assessing. So it's not, they call it functional unit because of you need to define its function. So it sounds simple, but it's really important to keep that in mind. And for example, we have this sulfite additive. So the source in the pig industry, they feed the source with an extra additive, and in the conventional industry they don't give the source that additive. So how do you compare the extra additive in the feed with no additive? So then you have to think about the function of you want to the function is that you get the meat. So probably you have to look at is there more meat from the system, or better meat, or whatever. What's the function of that system where you add these additive? So then we concluded, okay, maybe we shouldn't apply a functional unit of 1 kilogram of additive, but we should apply a functional unit of a kilogram of meat or a kilogram of piglets leaving the farm. So you have to really think case by case about the function of the products or the products you compare in your analysis.
Yeah, that was a very interesting remark indeed. Does anyone want to add something or has another example? No?
I think the example on this that Jona just said is also in the agriculture, like feed and agriculture, because sometimes we are adding as a biostimulant. So the plant just grows more, and then you need to go for the kilograms of the plant in the end, or like the amount of the fruit that you have or something like that, that can change quite a lot as well. And it's just another example.
Yeah, I think for the agricultural sector specifically, it's very relevant to take this type of approach. So, Mariana, I'm back to you.
Yes.
Do you want to share the question that we left aside?
Of course. Please bear in mind, you may already have answered, but since I'm not an expert, it may have escaped me. So I'll just go on with what was said. So from Nora, how do you plan to implement prospective modeling? Do you plan to follow specific guidelines?
So I think that was not answered completely. So does anyone want to add something to that?
I can give a short answer that actually we should have another session about harmonizing prospective LCA guidelines, because there's no harmonized guideline. So it would be nice if we have one, but currently there's no harmonized guideline. So there are studies and there are specific approaches, but yeah, you have to choose. And if one chooses the one guideline or one approach and the other one chooses another one, then you get different outcomes. So it's the same situation.
Yeah, and just before you jump in, Jean-Baptiste, I just would like to add something as well. So there are some guidelines for the bio-based industry, at least. So maybe that's something we could refer to in the algae sector. And there is also EU project that have been looking into this specifically. And I would like to mention the EU Aligned project that has done a lot of work on harmonizing LCA for the bio-based industry. And so the aim would be to try to use as much as possible existing guidelines for the bio-based industry and try to apply it specifically to the algae sector. And I think that's in my opinion, that would be the way forward. Jean-Baptiste, maybe you want to add something.
I was going to mention the Align project, but thank you for doing that. There was one other thing about this. Yes, that's it. We have also, Nora, a Algae LCA community of practice LinkedIn page. And this is actually for anybody here. So if anybody wants to join such a future webinar, you can also join the conversations in that LinkedIn group that will inevitably be taking place there in order to plan that webinar. So your input, Nora, would be more than welcome, as would that of anybody else who's interested in partaking there. So if you want to join, just add me on LinkedIn. You can just find me by searching my name, and then, because it's a closed group, I then have to invite you. So please just mention as you're adding me that you want to be added to the group.
And that could indeed be a very interesting discussion topic for such a group as well, trying to move forward on this matter. Tom, would you like to add something?
Yeah, muted. Yeah, we do try and use some of the things that exist for non-algae products. So, for example, the European Commission's got LCA for CCU, but yeah, with the intention, scientific guidelines to hopefully influence future policy on LCA carbon capture. So we use that as a guideline for how to deal with things, for example. And another thing is just, I think that since we're in a chaotic stage at the moment of harmonisation, we just all need to speak to each other more and be aware of what each other are doing and what different developments are happening, because 15 years ago, LCA and algae are still not aligned, but there weren't that many of us, so at least we knew each other. Now there's loads of us. Look, there was about 100 have dropped off, but there were about 230 people in this event earlier. So yeah, we need to make more effort to just speak and use things such as the LinkedIn community to try and communicate with each other more generally. Come to Newcastle.
That's very good remark. So yeah, hopefully we can just join each other on this LinkedIn group and continue the discussion as well later, because it doesn't stop at the end of this webinar, right? This webinar should be just the start of it. So yeah, we're all looking forward to continue the discussions. Any other questions, Marina, from the discussion?
Yes, we have 4 pending questions. Sorry, maybe
Good.
5.
Okay.
Maybe after we can also, Melanie can share the result of the slides of the survey. So okay, I think it will be interesting to share.
Yeah, I think so too. Yeah, thanks.
So I'll go on with the last question from Emma. I have a slight tangent question. I'm sorry, this is 20 minutes ago, but is there any databases or information that could be shared about costing of algal production across different scales? The different scales and the associated companies' methods and LCAs. If I can repeat if necessary.
So I think by costing, is it like looking at economic data, right? Or
yeah, costing.
Yeah.
Costing.
Okay.
Sorry.
Yeah. Does anyone have any inputs regarding economics? Has anyone done a life cycle costing, for instance?
We have done some like costing analysis or TEA, but it's really hard in this sector to find the data. So what we have been doing is just contacting the different suppliers. And that is a little bit hard because a lot of the things in the algae is really built specific for the case. So even the large facilities, they were designed and built specifically for the case. So the cost is still quite high and vary quite a lot. And I think this is a huge challenge, especially like in the research projects and the economic analysis of the facilities. Considering the different scales, as I said, like the idea is just like they are doing a small growth in this kind of reactor, how much this would cost in the large scale, I would go supply by supplier, and that is what I have been doing so far. But as I said, I understand that this is quite still challenging, especially because of the not standard market products for this sector. yet. I don't know if someone else has something to jump on.
So anyone else with experience with economic data, techno-economic analysis, life cycle costing? Nope.
I mean, we've done TEAs as well, but I think Lais summarizes this well. It's early days for a lot of these value chains, so it's hard to do this kind of data, to provide it in a format which will be reliable and reusable. A lot of these startups companies are, we mentioned, privacy or sort of sensitivity of data. A lot of the companies don't necessarily want to share their processes either. So this is difficult. It's a difficult thing to be able to get a hold of.
Okay, Marina, was that the last question, or?
No. What are the various methods for scaling up pilot or lab scale data, and which ones are most recommended?
So I think we kind of mentioned this, but no one really added more information regarding software, simulation software, for instance, to upscale data, such as Aspen Plus. Has anyone any experience with such software? Or maybe learning curves as well? No. These are not used commonly in the algae sector, I guess, but also Lais, for instance, if you have access to upscale data directly, you wouldn't need those type of
We
simulation
also
software.
have been using some of super Prospective design and trying to be using scale like that, but it's the same as Aspen Plus. Like, I think it's just like you still need to input the information of the scale that you wanted, and still need to. They just have some more material in the background.
So Super Pro Designer would be another one. Okay, anyone else wants to add about really method to upscale? Maybe that's a topic we can take into the LinkedIn group to try to see if there are other experiences of other LCA practitioners out there. So I think we can go to the next question.
Okay. So Karina asks, what would be suggestions from the experts for those new to the field? What are some common mistakes to avoid, and what are the key things that should definitely not be done when conducting LCA on algae systems?
I really like that question. So anyone wants to jump in? Tom.
Yeah, I think one of the things I've noticed, people who are so I went to one conference and there was a professor from one organization, I'm not going to say where, but he presented an LCA on something. It wasn't about algae. But at the end, after he'd finished, I went over to ask him a question about his climate change indicators. And his answer to the question was, I just pressed the climate change button. And I think one really important thing for when you're doing LCA is to understand, don't just believe in software. Don't just believe that it's going to work. Understand what's going on behind it. So before doing anything, understanding stuff about climate change indicators, understand what the impact categories are doing, and get a background knowledge before just trusting software, because all of the software has bugs in, some incredibly bizarre ones in some of them. But yeah, and read the standards, and read the ILCD handbook. It's massive, but it's really good. It's far bigger than the standards. It's actually explaining to you how they work. It's far bigger than the ISO standards. It's brilliant. Read that.
So I think learning LCA can be very overwhelming. So I think that's a very good question, actually. Where do we start? Has anyone or does anyone else want to share her experience with starting working on LCA? Because it's most people actually say it's a hate-love story working on LCAs. it can be frustrating as well. So maybe Lace, you want to share your experience on how it went for you when you started using LCA?
Yeah, for me, it was started in my PhD, but as you said, love-hate story, you start with some software, and I think one important thing and common mistake to avoid is especially like when you're choosing the providers and things, sometimes if you start to go a little deeper, and that is why the software choose is quite important, because if you just go for the black box one, you don't have this kind of access. But if you start to knowledge, as I said, like there was a spirulina in one of the databases that if you start to see what the provider is coming from, it comes from like both and uva, you know. So you need to be careful in understanding what you're like really inputting as providers, just not like you have the databases. And as people said, like everyone can really submit data for the databases. I think they have a kind of like verification before putting on, but I don't trust completely on that. And they have the information, like, so all the data that we're putting in the model, they have the description. So it's not because it's, oh, we are using Equivent, that means that we are using all the same data and we are using all really reliable data. We need to see where specifically the data that we are picking up from the Equivent, for example, is coming from. And having this understanding, I think it's quite challenging, sometimes takes much more time than people that are not working on LCA predict, and sometimes more time than we predict, and I think we need to take that in consideration.
Very good points. Does anyone want to add something? Tom?
Please don't mix databases. There's some wonderful LCAs out there. There's one for a car, I can't remember which car it is offhand, where they took the EcoInvent database and the Gabi professional database, merged them together to make one big database, because then it had more data. And then you've got two lots of databases that have got different assumptions. And it's a wonderful piece of work, but fundamentally flawed. Don't try and combine databases. I know it's possible, but please don't. That's good advice for people starting. Please don't do that.
Morten, maybe you want to add, maybe share your experience with like LCA and what software are you using and what should be the things not to do when starting with an LCA.
I prefer Simapro, but mainly yes. I think the best things have been mentioned. You need to understand what you're inputting into your analysis model, which types of data you're including, and which types of, let's say, assumptions are already being made when you select something. So perhaps really read through what you're what you're actually adding to your model to understand. It could be hidden somewhere that you're trying to add corn, but it's actually corn syrup. Someone forgot to properly explain, or something similar. It's attention to detail in this case.
Yeah, okay, yeah, makes sense. Marina, is there any follow-up on the question, or?
Yes, so we have 8 minutes left, and I think it would be nice. We have 2 questions left, and still we have to share the results of the survey. So maybe we can quickly go over it. We have a question from Laura. Have you faced any challenge using PEF method? Did you miss any impact category or further guidance in any particular aspect?
Who wants to jump in?
I can answer that. I think it's good to know that PEF is a very general guideline. It's a very good guideline, but it's for everything. So to say, it's for food and non-food. So therefore, you have this PEF CRs, the category rules. So that's product group specific guidelines based on PEF. But there's not yet one for algae, which is pity. So it would be nice if we can develop one in the future. Sorry, what was that? I forgot the question. My experience about PEF, applying PEF, Yeah, if there's PEF-CRs, you can conduct a very detailed LCA, which is comparable, because a PEF, the objective of PEF and the PEF-CRs is to get harmonized outcomes. So that's really, really nice. But there are a few challenges still. Even if you have these PEF-CRs, their outcomes are not comparable, because per product category, they define the hotspots, and within the hotspots, so which activities do have the most environmental impact. And for that hotspot, you have to collect the primary data and you assess them. But for another product group, it could be completely different. So it's not always that they are one-to-one comparable. And now we're developing within the LCA community a PEF-based guideline, which can be applied for all products, but it's not there yet. So it does have, it's a really nice harmonized standard, but it also contains some challenges.
Thanks. I think Marina, you take over for the last question.
Okay, so from Maris, are there, to your knowledge, attempts to use AI to make valid and effective LCA applications?
Any
I know that.
comments?
Oh, sorry. Can I?
Go ahead, Tom. Yeah.
Yep, definitely, because people who are doing it keep getting in touch with me. So there's quite a few different groups trying to do it. We'll see how it goes, I guess.
So what are the applications and where AI is used exactly? Is it to fill in data gaps? Is it to make calculations? Can you tell us a bit more about this?
I think there's a lot of the groups and organisations that have got in touch with us that don't really know what they're going to use it for, but they know that you should put AI into everything. You can use it to do things like checking of models, etc., and use it as an assistant to help you going through a very complicated process. Yeah, review your models and find errors and compare life cycle inventories with your models. We can do stuff like that now. So I wouldn't trust it to build anything, but you can certainly use it for detailed validation of your models.
Okay. Melanie, maybe it's time for you to share the outputs of the survey.
Understand. Can you see?
Yes.
Okay, so that was the first question about databases. Is a word cloud? The bigger the word, the more this word was, or database was suggested.
Oh.
Yeah. Is there something that comes to your mind? Someone is surprised or not at all, or?
There is a related question also, I think, in the chat. Are there any open access LCA databases specifically tailored for microalgae-based processes?
No, but for example, they have this Silka that is for aquaculture. So maybe if you're comparing two products of aquaculture, this is a nice place to go as well. Agro-Based would be more for the agriculture products, and so in some things that we can like try to get data from. Some of them I haven't heard about it, and SOCA would be more the social LCAs, so you can see like some different like inputs here.
Should I go on to the next one? This will be a bit busier because you can see lots of single answers to processes that are difficult to model. and you will see the answers based on whoever submitted it first. Don't know appears a couple of times. Lack of databases, data library, I see a couple of times.
Okay, so I think this list would be very useful to try to identify what processes are on this top priority lists, I think. So it's maybe something that could be processed after the webinar, and we could share the outputs in a bit more summarized way, maybe.
Yes, it's one of the things that we will do in the coming days, probably to summarize the list. Might take a little while, and we can definitely share it. I saw it in the chat. Someone asked. I'm sure we can share it. Yes. And then there was a last question, and it was about default processes. If things are happening in different locations, so there is a very particular question, I guess, also. A couple of answers which I can also share if there is interest. I see the pink one says ask experts. So I guess, as was mentioned earlier, there's a LinkedIn group. The link was shared in the chat, and there's a couple of experts in already. Everyone is welcome to join and then ask all kinds of questions, I guess.
Can I add something?
Sure.
Yeah, if there's a default process in another location, the tips that are given here or the reactions are quite good, of course, but you can also use that proxy, and there's already mentioned change the energy mix to a regional mix, but you can also change, as you have good software, not maybe the black box of EcoChain, but now you can change the processes based on the literature you maybe find about the region where you're looking at. So even if there's a proxy process in the database which is not in the region that your product is in, then you can try to remodel it a bit based on literature or on interviews, or so you have a good base, and from there you work on.
Any other final comment? If not, I will hand over to Leah if she wants to say some final words before Marianne will close our session today.
Yeah, just to say thank you to the speakers. I think we started to have a very good discussion about many interesting topics, and now I think we all need to make sure that the discussion continues beyond this webinar, and I think that should be our main concern as LCA practitioners in the algae sector. But I hope that the attendees learned something from those discussions, and I was very happy to facilitate it. So thank you.
Well done, Leah. Thank you.
Okay, everyone. So as you know, the webinar is being recorded, and we will upload the video to YouTube within the next 7 days. You'll receive a link to that connection, and as requested, we'll also share the answers to the survey. And as we come to the end of today's session, I would like to sincerely thank all of the speakers from the different projects and institutions for their valuable contribution. This is very important as we take a step forward. A big thank you to all of the attendees for joining us and engaging in this discussion. We encourage you to continue these conversations as provided in the link by Jean-Baptiste to the group. We could only cover a small topic today, but we still have a lot of work to do ahead. And this is, once again, thank you for all your time and participation. And we hope you found this session insightful. And we wish you a great rest of the day. So thank you very much, everyone.
Thank you.
Thank you. Bye-bye.
Have a nice day.
Thank you.
Bye.